Okay.
Yeah. Welcome to Solarchat March meeting. We're starting our fundraiser April 1st. We've been helping a guy in Brazil. Some of you on Facebook have seen him, Kai Crespo Moraes, who has built his own pretty nice observatory with nothing and is using very rudimentary equipment. And last time I was there, I gave him a telescope. And now with our economic situation in the U.S., it's much cheaper for me just to send money. And he has the ability now to purchase basic solar imaging gear online in Brazil. Uh, for instance, it would cost about, if I sent him a $3,000 lunch solar telescope, it would cost about $12,000 by the time it got there with shipping and customs. So it's easier for him to just buy it online there, and he still pays a little more than we do in the U.S. But sending money is cheaper now than trying to get something there. So that's what I've been doing this last year. And if you haven't seen him, he's got an observatory called the Maunder, like Maunder Minimum, the Maunder Observatory that he built himself. It's got a sliding roof. The guy's about 25 years old. And I met him when I was in Brazil when he was in middle school. Couldn't speak English or anything, but he was just a fascinating young man who was very, very interested. So I decided to support him. And we still are supporting Pranvera and Astronomy Outreach of Kosovo. Things are a lot harder now because of our stupid economic situation here, as everybody knows. So anyway, just letting you know, the forum is paid up for 3 years. So unless something horrible happens on the server and Boyan is no longer with us, we should be good with the forum being as fast as it is for another 3 years. But I did pay that in advance from personal funds and just showed it as a donation to the nonprofit. So anyway, long story short, cough it up, suckers. It's time to pay. And I'm kidding, of course. So I'll be at NEAF the second week of April, the second weekend in April, if anybody else is going. And I'll have our last remnants of solar glasses from Kosovo that Daystar generously donated. And we will be giving those away. They have a picture of the observatory in Kosovo on them. And there's about 800 of these left. And I'm going to take them there and give them away and give them to Pranvera, who will also be there. And an interesting thing about NEAF this year is that Michelle Thaler, I don't know if any of you recall that name, but she was very popular on the Discovery Channel on astronomy shows for many years. She's an astrophysicist out of Cornell. And she's going to be, I'm very excited to meet her because I really like her and like her work. So she's going to be speaking at NEAF. And for some reason, they still invite me every year. And my job is to walk around in the crowd and get everybody excited. That's all I do, you know, which I seem to be pretty good at. So me and Gary Palmer from the UK are going to be walking around exciting people. But I get to go to the speaker's dinner, so I'll get to hang out with Michelle and maybe talk to her a little bit. She was also a student of Carl Sagan's, and I won't talk much more, but I'm rereading all my Carl Sagan books because I'm very depressed about what's going on in our country, and I'm trying to find some inspiration. So I'm rereading everything from Carl Sagan, and frankly, it's more depressing than it is inspiring because he was right about everything 30 years ago. But what have you got for us this month, Alexandra?
Well, I was just wondering whether you could tell us which Carl Sagan books are good ones to read, to recommend.
Well, probably the best book he ever wrote was Contact, but it's fictional.
All right.
And other than
Oh, is that the same as
Cosmo,
the movie?
It is.
it's a lot better than the movie.
Ah, I
But
didn't
you know, the
realize that was
movie,
the Carl Sagan.
yeah, Carl
I love
Sagan
that
was
film.
he was not really well liked by the astronomy community, to be honest with you. He thought they were all full of themselves and preventing science from getting out to the public, and he was not well liked by the 60 hours in the middle of the night living in their mom's basement astrophotographer types. But he was well loved by me, and he inspired me in my life and changed everything for me. I was a student of his. That's my first college quarter. But his books are mostly about skepticism and how the scientific method is crucial to the species survival. And he put off a lot of religious people with his books and everything else. But when I read his books, it's like I'm talking to myself, and it really inspires me a lot. So I would recommend Demon Haunted World. It's a short read, and it's in small chapters, and that's probably the essence of every other book he ever wrote in Demon Haunted World. And his wife, Anne Druyan, wrote these books with him, and she's still alive, and she still does lectures and things. But if I were going to read one Carl Sagan book, it would be Demon Haunted World.
Billions and billions of
That's
stars.
that's my next one to start. There's actually, he never said that in any lecture. He never actually said that ever.
On Cosmos?
No, never said it. It was attributed to him by
Yeah.
a TV show that interviewed him afterwards, and it became his famous catchphrase, which he never actually
Billions.
said or wrote. So his next book was titled Billions and Billions.
Some billions of stars.
And that's the last thing he wrote before he died. In fact, he wrote the last chapter as he was dying, and his wife finished that chapter. It's an absolutely fascinating book, and I'm reading that one, starting that one after I get off this meeting. But anyway, those things inspired me when I was younger. So I will say one point.
So what was the demon? What was the demon that's haunting the world?
Willful ignorance celebrated by the masses. And this all throughout history, all the different civilizations that have embraced these make you feel better stories rather than the actual wonder and brilliance of reality. And it's just an example of how all these civilizations have gone off the deep end with stuff to make themselves feel better rather than reality. But the main gist of that book is that the scientific method is the only thing that's going to save the species. Real facts versus bamboozlement by leaders, which is what we're experiencing now, as we can all see. So, but he did say something really important about outreach that always stuck with me, and that was this, and I learned it right off the bat. Students, young people couldn't care less how expensive your telescope is or how much cool astronomy imaging gear you have. They don't care. They, almost all of them that I encountered, would much rather have the 20-cent pair of cardboard glasses to look at the sun than they would look through my $30,000 solar telescope. And the whole point of outreach is not to show off your gear. It is to produce curiosity any way you can. And you're not going to teach a kid about solar physics in a 10-minute interaction and outreach, but you are going to spark some interest and wonder. And that was inspiring for me to read, because that's really gone downhill in the US lately. No one wants to know anything anymore. So rereading that made me feel a little bit better. And that is, inspiring wonder, which I'm really good at. And I think I'm really good at it. Making people want to know something because it's so cool. And in almost every topic, every scientific topic, every social topic, the reality is so much better and so much more amazing than any bamboozled nonsense story people make up. Like, the reality of astronomy is so much better than astrology or the feel-good stories of the zodiac sign and all that stuff. When you actually know how things work, there's nothing to replace that high you get in your mind. And that's what I'm promoting. So I don't worry too much anymore about how much cool stuff I have set up. It's all about can you get that kid or young person or adult to think about something that they're not comfortable with and learn about something that they never thought about before. And that's the point of it. I'm done. There you go. I know I talk a lot.
Anybody got any burning questions at all?
Who's going to go to watch the solar eclipse in Spain or whatever this summer? Yeah. Okay.
No
Maybe
one?
me. Maybe me. I had an offer. Someone I know from the U.S. is planning a trip, and so he has a place in a house or something somewhere near Leon. I think it said Leon.
Leon,
So
yeah. Northwest Spain. Yeah.
and so I guess I checked Ryanair and like that kind of thing. So it is possible to get there from London not too
Yeah.
Uh,
Uh, Flights are still quite cheap. You can fly into Bilbao or Madrid. And yeah,
mhm,
it's this 26 and 27 for people in Europe will be very accessible eclipses. And then we have nothing in Europe for at least another 25 years or so. It's late the 2050s, I think, before another one hits. And that's in Eastern,
yeah,
far over Eastern Europe. So, well,
yeah.
we're getting them. The upcoming one is, I kind of rate it as a 50-50 chance, to be honest.
Hmm.
And then next year is, yeah, I'm heading to the southern tip of Spain for that one. And like that'll be over 4 minutes from the south end of Spain,
Hmm.
or Gibraltar if you want to fly into there. And yeah, I mean it's like 20% chance of cloud, so that'll be really good. Well, we're
Hmm.
going.
Hey, I know Pedro Ray is going, and but this is Steven, and
That's
we
right.
had
Yes.
plans to go together.
Yeah.
Like we've been to Tunisia together before doing
Mm.
outreach for a while, but due to recent events and recent political changes, my wife has decided that that's not a good idea for us to travel internationally anytime soon.
Yeah.
But I know Pedro is still going to go. Uh,
Yeah. There are issues with going into some of the North African countries with optical equipment. I know Algeria is one. I'm told there are another two. Might be Libya is a second. I'm not sure of the third. But they will, certainly in Algeria, they will confiscate things like binoculars, any telescopes. Yeah,
they did actually try that when I was in Tunisia the last time. The customs people, I had a dozen pairs of sunoculars,
mm,
and the guy took one out and looked in it and saw that they weren't real binoculars
okay.
in his idea. And they
Yeah.
did attempt to confiscate them, but the guy in Tunisia that met us at the airport went up and talked to him, and that was the end of that. They just forgot about it. So it's
Yeah.
really good to have a local that you're meeting.
Definitely, yeah, because I know someone who went to Algeria in the last 12 months and they confiscated the binoculars at the airport and they got them on the way home.
Mm.
So it's to do with difficult political situation there at the moment with various factions, and they're just very super sensitive about
Yeah,
anyone using equipment like that for untoward purposes, essentially. That's how they view it.
yeah, that's
And
the
so,
world we
Michael,
live
where are
in.
you going to go? Which part of Spain exactly?
So for 26, I'm flying into Madrid and
Hmm.
I'm hiring a car from there and I'll just see what the weather's like on the day.
Hmm.
And then on 27, I'll be flying into Malaga and I haven't booked it yet, but that's the plan. And stay somewhere around the southern tip of Spain. Uh,
Hmm.
Gibraltar, if you're in the UK, obviously Gibraltar might be a potential target, but the downside will be that if you need to get out of there
Mm.
and you have a queue of cars waiting for
Hmm.
passport control and you're in a
Hmm.
hurry,
Hmm.
it might be a bit of a bottleneck.
Hmm.
Yeah, I'm going to stay in the UK for the 26 one,
Mm, mm,
because I think that it's going to be about 90%, so that's pretty
mm,
good. So I was going to do some outreach instead if it was,
mm.
like clear. And then 27, I was going to go to Spain. Um, so I was going to go and visit Andy Devi, and I think Nick Spencer's going as well. So and we're sort of like all going into the same place. You know what I mean? So we're going to sort of like try and go drive down to like the southern tip of Spain. So probably the same place as you're going, Michael.
Yeah, I
But
could bring
I
up
don't
actually.
think we're going to go to Gibraltar because, like you say, Gibraltar usually sits with a hat of cloud over it. And also, it would be like a terrible bottleneck. And also, most of Gibraltar isn't on the sunward side, it's on the northern side. So it would be a really bad place to go. Um, so I don't think you'd want to go to Gibraltar.
Yeah. And for us, well, in Ireland, we don't have direct flights anyway. So I'll just share my screen.
Hmm.
Yeah. So all along the southern tip, in theory, see that?
Yep.
Hmm.
Yeah.
We'll see the eclipse. And now, of course, all the fuss is about Egypt and going over the pyramids and so on and so forth. But that's been
Mm.
booked out for the last, whatever, 10, 15 years, costing an arm and a leg. And personally, I don't fancy being in 45, 50 degrees Celsius heat, to be honest, with a crowd. Then you have Tunisia, as you said, and you could go into Tunis, and then you have Algeria, and of course Morocco as well. But it is quite a trek, like certainly from Ireland, the flights are into Marrakesh, and so then you have to, a few hundred K of a drive up there. Um, but then the option I think here is, in terms of affordability, access, statistically, what the weather's like. You have Malaga, Marbella, Almere, you have plenty of airports, Cadiz, and then you have a lot of fuss discussion in the UK media about Gibraltar, but it's quite small and it actually isn't a southern tip. That would be down in, I'm not sure how to pronounce this, Tarifa. I'm not sure if that's the correct pronunciation, but that gives you over 4.5 minutes. So that's plenty good enough. I'd be happy with 1 minute, let alone 4.5. So if you get that.
I'd be happy if it was just clear.
Yeah,
Yeah.
yeah. And there's good roads along the coast. So it is morning time. So sun will be rising in the east. So maybe somewhere along, it depends. I mean, you're seeing Gibraltar, that tends to get cloudy, yeah?
Mm.
Okay. So who knows? It may be somewhere along an east coast, somewhere. It's not directly over the horizon. It is up a bit, but at least you're looking over water. Hopefully that keeps it atmosphere somewhere stable and cloud free.
Yeah, I've been to Gibraltar many, many times,
Mm.
and I would say that only maybe about 40% of the times that I've been, it's been clear.
Oh wow. Yeah.
So I wouldn't make that a target because it's funny because the whole place can be completely clear. Gibraltar, the rock there, and then it's like a little cap, and it's just like a
Mm.
little cloud that sits over the top of it.
Mm.
And it takes a long time for it to clear in the morning.
That
Yeah,
So,
sounds
let me
like England.
pan, pan down here to statistics for Spain. Thought there was another map here. Percentage of sunshine, Cadiz, Almira, 78, 79%. So I think that's pretty good for eclipse. That's nice and close relative to us.
hmm.
You guys in America have had you've had your turn. We've had to fly over there, so it's time for you guys to come back here now.
Yeah, one thing I learned in 2024 was that weather prediction has gotten on a 7 to 10 day schedule has gotten really very good. I was actually amazed, and the guys who really did well were the ones who were very flexible.
Mm,
And I
that's
was
a
not
good.
one of them. I sort of made a commitment to a certain place in Texas, which turned out to not be good. But
Yeah.
it was actually amazing that 7 days ahead, they were able to predict within 2 or 3 hours when the clouds would be there for the place I was in Texas. I was
Mm,
actually kind of stunned.
mm,
And when I got there to this like campground in Texas, I think I got there a couple days before, and then the guys who were there said, "We're leaving. We're going to Oklahoma because this place is going to be terrible." Uh, and that was maybe three, as I said, maybe 3 days before. So, and the I think the technology of computer simulation of weather, and now I think they use AI actually as well. It's not just purely mathematical. And but I think the problem is for eclipses is that you sort of have to make reservations if you want a place to stay.
Mm.
So it's only if you're willing to like live in a car or something that you can be truly mobile, I think,
Mm.
My
or
Yeah.
a camp or camper. I guess a lot of people do campers if they're quite serious about this, at least in the U.S.
mm.
But I don't think that's really the case in Tunisia or Spain or something. I don't think you can like live in your car. Uh,
yeah,
so
yeah. My
Tunisia would
my
be an excellent place to see it because I don't think I've ever seen a cloudy day in Tunisia. I mean, it
Yeah.
was never cloudy the whole time I was there, but it was 40, 45 degrees C. Uh,
Mm.
but
that was
I can't recall there
Exfas,
ever being a cloud.
Exfas or something. Did you say like which place in Tunisia?
Well, I flew into Tunis and stayed around uh, Tunis most of the time, but we did go
Okay.
south to Tatooine, they call it, where they filmed the Star
Mm.
Wars, original Star Wars. And I didn't see a single cloud the entire time I was in Tunisia, but it was hotter than
Mhm.
hell the whole time.
Hmm.
So
The stats have it at somewhere between 76 to 85% sunshine.
yeah,
That's pretty
that'd be
good.
where I would go, except that I'm scared to leave the country right now. They may
My
not let me back in.
my eclipse chasing brother's going to Egypt with his best friend
Wow.
for that one. And Doug, he ran into the same issue. He's from Ohio, just 2 hours from me. Went to Texas. I stayed in Ohio. It was perfect at his house.
Mhm.
He was clouded out in Texas.
Yeah. Yeah, exactly.
Yeah,
Yeah.
Yeah. Yeah.
We were in
Uh,
we were in Texas in Dallas. That's where we used it as our base. And on the 20 morning for the 2024 eclipse, yeah, we had to drive up into Arkansas to try and get it. Like a 4.5 hour drive. So yeah, but if you have a car and good roads, you can cover quite a distance.
Yeah.
yeah. Yeah. Yeah, but my point was, I mean, this was a couple of years ago. The weather prediction technology was, I was very impressed with. So, by this year or next year, I'm sure it's going
Mm.
to improve, as computers get better and so on. So I think if you can, as I said, 7, 10 days, they're really, really good now. So, but um, I guess that would be the ideal thing, is if you could be flexible on that time scale of a week or two. Um,
Yeah.
so I'm
I
I'm
don't
kind
know
of
if you
hesitant about making plans like 3 months or 12 or months in advance.
well, one of the reasons I picked Madrid is that it's right on the southern boundary of the
Hmm.
eclipse line for 2026.
Hmm.
Um, but like most capital cities, the roads radiate into it. So
Right.
by staying outside the pass, accommodation is more affordable. And
Hmm.
then you just drive into it. The eclipse is on late in the day, so you have plenty
Right.
time to make a decision and drive in,
Yeah. Yeah.
rather than being in a fixed location and then trying to move later
Right.
in the day.
Right. It's awfully low on the horizon, isn't it, this year?
Yeah, so up at Leon, it's about 10, 11 degrees, and it's
Yeah.
getting lower as it heads east. So
Yeah.
it's low. That's why I would rate it at about 50-50, even though in theory you could have more sunshine. But when it's so low, you need quite a gap of clear sky to try and see it. And
Hmm.
the danger at that time of day, that time of year, is that you could get cloud buildup as the day progresses. So it could be
Right.
clear where you are at noon or even
Yeah.
3 p.m. By the time eclipse comes, it could be cloudy. So
Yeah. And you need like a good horizon without
yeah,
trees and
oh, correct.
buildings.
Yeah.
Yeah.
But if you go northwest of Spain, say midway between Madrid and Leon, you're up in a dry kind of plateau at that stage at altitude. So Spain actually is the second, on average, the second highest country in Europe after Switzerland. But it doesn't have the same rugged terrain in the same way. Just a lot of the country is just at a high altitude. So that means that it is relatively dry in that region. So and sunny. So that's considered a good area.
Yeah. Yeah. And are you bringing equipment with you, or just your eyes?
Just my eyes, I think, and I have a small little pair of binoculars, 2 by 54s, I think they are. Just they're more like enhanced, like opera glasses. They're like enhanced naked eye observing, really more so than anything else. So just to look at the corona, try and see a bit more detail, to have it a bit sharper. I normally bring some camera gear and stuff, but I might keep it a bit simple for this one. Let's see.
Michael, is it?
Warren, is your brother a U.S. citizen that's going? Warren?
Is he a U.S. citizen?
Yeah.
Yeah.
Yeah. Yeah. Because
Yeah,
there's a pretty.
he's going with one of the tours. He and our best
Oh, okay.
friend,
Okay.
they travel extensively, and he's been chasing eclipses since his first one he went to was Hawaii. He took the whole family, and totally cloudy. The rest of them
Because
he's
there's.
seen. Texas, he got to see a little bit of it, but if he'd have stayed home, he'd have had his backyard been perfect.
Yeah.
Yeah. So look at
There's
the
a pretty
draw.
serious travel warning on the State Department right now for Egypt.
Yeah.
My experience in Texas was serendipitous, that it was cloudy until 10 minutes before the onset of totality. And it remained cloud-free throughout totality, and then it clouded up again. So
Wow.
we were very, very lucky.
Wow.
We were staying with friends close to the path of totality, so we got an extraordinary view. I didn't get extraordinary pictures, though.
So, you know, in 2017, Paul, you're in Australia, right? In 2017, the schools, all the schools in the state of Georgia canceled the eclipse viewing that I'd set up for the whole state and sent glasses everywhere. They all canceled it because of stupidity. And I ended up staying home, and our farm just north of my house that my family owns, Natalie's family owns, was perfectly clear for the entire eclipse, but the school that I was going to be at was
Yes.
totally overcast. It was
Wow.
completely
Wow.
clouded out. So
But
it
that
ended up
makes
being
me
great for me.
a bit skeptical about long-range forecasts when
Yeah.
it can be
Yeah.
so variable on a 30-minute to 30-minute basis. It's always going to be probabilistic.
Mhm. So, Michael, is that a stock image behind you, or is it one of your own?
No, that is nice. Let me turn off that camera actually. You'll see that. So there it is. Now that's one of my own.
Excellent.
So that is a HDR of about 13 images from 2024. And actually, what's interesting is if when you observe eclipse to eclipse, you can actually see differences between solar maximum and solar minimum. So this one's at maximum, so the corona is quite active in
Right.
all directions. Whereas a solar
Yes.
minimum, you can get longer, stronger streamers, but there might be only be 2 or 3. But that is like a HDR blend of about 12, 13 images combined.
Yeah, it's good.
Thanks.
Yeah, it's interesting to compare with 2017 with Alexandra's excellent solar eclipse image. You can see the difference between a solar minimum-ish versus a solar max.
Mm-hmm.
Yeah, for sure.
Mm-hmm.
Yeah, because in 2017 there was sort of like about 3 long streamers, wasn't there?
Yeah,
Yeah.
it's like 2 horns and a beard type thing.
Yeah. Whereas Michael's picture is like a halo around his head.
It is actually.
Yeah.
You look very
Yeah.
saintly.
There you go.
Very, very divine. Yeah.
Well,
Yeah.
if you can't go to the eclipse, you can always stay at home and look through your H alpha scope, and then just put a piece of cardboard over the top of it,
Slowly
and then slowly pull it back away, and it'll be exactly the
not quite.
same.
So, Michael, what sort of exposure ranges do you set on your DSLR?
So
'Cause I hear a lot of these things about bracketing, and I have no idea what that means.
okay, well, I can show you a couple of slides because I gave a talk recently on a solar eclipse, and it might explain the whole issue of dynamic range. Let me bring it up.
Yeah, bracketing is something you should know how to do. It's useful in a lot of different photography. It's just grouping exposures together on one side and on the other side in the center. It automatically takes one brighter and darker, and whenever you take the center one.
Let me share my screen again.
All right, because when I went to the
forward.
eclipse, I just took different images on different exposures.
That's basically it.
Yeah.
Bracketing sort of automates it.
I'll
Yeah.
skip forward here, but it's this is just a talk I gave recently. But okay, here we go. So particularly, can you see that?
Yeah.
Okay. So the dynamic range of the human eye, I mean, the human eye is a fantastic camera, and it's, as a dynamic range, it's far superior to most cameras, DSLRs. So a DSLR, when you take an image when you're sitting at home and you look in a room, you can see a dark area in the room and you can see a bright computer screen at the same time, no problem. Whereas a camera can't get that. You either have to expose for the dark area to see the image, or the bright area with one single image will either have one washed out or one blackened out. So what you're seeing with a camera in effect is everything below a certain point will be black, or everything above a certain point will be white. So the trick is to take a series of images that are centered around the darker area, the middle area, and the bright area. And then you're essentially artificially extending the dynamic range capability of the camera to try in some way match what the human eye is able to create. So if I was to start off with exposure, say a very short exposure like this, you're just about able to see the prominences and tiny elements of the corona, but then the sky looks black, which, as you know, isn't real because the sky is never that black in an eclipse. And as you pan forward, now you're washed out right near the edge of the limb of the moon, the sun, but you're able to see the mid-range areas of the corona. And as you gradually extend out further, now you can just see it get more and more washed out. You can actually at this point see I'm not sure if you can see it in your screen. Can you see sorry, let me get up a
Yeah,
laser pointer
about,
here.
yeah,
Are you able to see my cursor on the screen at the
Yeah.
moment?
yeah.
Okay. You might see a double star here. That is about magnitude 6 or 7 or something, I forget. And you're actually getting hints now, possibly you might see on your screen of Earthshine as well,
Yeah,
where the sun is bouncing off the lit part of the Earth's atmosphere, reflecting off of the Earth side of the moon and back again. Now, obviously, you'll never see that with the human eye to that effect, but you're just pushing the limits. Now we're out to create a dynamic range that actually goes beyond what the human eye is able to see. But by combining all of them, then you're able to end up with an image like this by blending them basically in. There's certain processing methods in Photoshop specifically for eclipses of how to blend them all to come up with something that is more in line with what the human eye can see. And if you go beyond that, then into 2027, now I've stretched it a bit more. You can see the Earth shine, and you can see that triangular shaped corona that we were discussing there a minute ago. And that's Regulus in Leo there just to the left. But that's why we bracket in taking a range of exposures to try and blend them to create this HDR, high dynamic range type image.
But how do you know what to set your camera to
Oh, okay, right. So
before you go?
yeah, okay. So I mean, there are various guides. Like Fred Espenak has a guide, for example, on different exposures to use. So I would typically use maybe not too high in ISO 200 or 400. And then there's a free piece of software that I use on my laptop that I would bring with me for this. So I let the laptop control the camera because with the range of exposures here, it would be extremely difficult to try and play with the camera to get all of this going while trying to watch an eclipse. You'd be very high, most likely to make a mistake and not really enjoy the eclipse. So I set a range of exposures, I think from about 1,000th of a second or maybe one 10,000th of a second, right up to about 2 seconds, and just a relatively even range of exposures. Some might be too dark, some might be too bright. I can select the ones I want, and then I'm able to bring them into Photoshop and blend them to create it. So it's but you're talking about in general fractions of a second for most of them. The longest exposure I think back here was that might be 2 seconds or something like that, just for scale.
Were you using a DLSR or a astronomy camera?
A DSLR 60D on a Canon 100 to 400 mm zoom lens with a teleconverter for that particular one.
I know if you are using a astronomy camera, like a full frame astronomy camera, let's say, then you can easily use SharpCap to write a sequencer script. But it doesn't really work with a DLSR, I don't think. I don't think you can use like DLSR with SharpCap really.
I don't think so. Yeah. But you're right. That would be the other way of doing it. Yeah. But you would need, with the time available, you would need to have a script ready because it would be very difficult to do it on the fly with any level of accuracy.
Yeah.
Time is so short, and the adrenaline and everything going as well.
Yeah.
But anyway.
Yeah. I actually have an interesting little historical story I can tell you about solar eclipses, which is, this won't take too long, but I gave a talk a couple of weeks ago, wasn't it, about the Eddington experiment, the famous experiment to test general relativity and so on. And then after I gave that talk, actually, on Solarchat, I sort of wanted to delve into the actual like images which this guy Eddington took in 1919, because I'd actually never seen the data myself. I just read about it in, you know, like papers, and usually it's papers about papers, right? You never really go back and look at the original paper necessarily. So I decided to try to like find the original data, and my idea was like, could I take like Eddington's original data and put them into our software program that we wrote and reanalyze it? So that was kind of my thinking. And I started looking around and I realized it was very hard to find the original data. And, it's kind of historical data. I'd say it's probably one of the great scientific experiments of the 20th century, actually. It's what made actually Einstein famous. And with some difficulty, and maybe I can do a share screen here as well, because it is kind of like an amazing thing when you see like images taken on glass plates from, what is it, 100 and more years ago. So let me do a share screen, because I was able to.
It would be interesting to know where those glass plates, the originals, are now stored. They must be in a museum somewhere,
This
surely.
is the part of the interesting story and a little bit depressing, but I'll get to that in a second. So anyway, let me see. Okay, I'll share. Okay, I guess I'm sharing the right screen, right?
We can
Looks
see
like
the
it.
files.
You see some files. Okay, so great. So anyway, I after searching the web, I found a German university which had received a copy of like Eddington's like data. One glass slide. Can you see that?
Yeah,
Yeah,
Yeah.
what a prominence.
Yeah.
superb.
So
Yeah.
Oh my
so like this
God.
is actually not an original slide, but what Eddington had done was he had made copies of his glass slides and sent them to a number of universities all around the world with the idea that if you want, you can check my result. He wanted to be like really honest about it and said, listen, if you want to redo my work, which was pretty hard to do, I suspect, in those days with the equipment they had, you can redo it. And out of all those ones he sent all around the world, apparently just this one survived. And it was discovered a couple of years ago at a university in Germany. And it was, dusty. Like if you zoom in, this is, it's full of like some dust, as you might expect. Looks like a photographic negative, right? And but even on this version, you can see that, for example, I won't spend too much time, but you can actually find the stars. Actually, the stars are mainly around here. So like that's a star, for example, and it's a very bright star. I think it's about magnitude 5. And then I think there's one star up here as well. But then what the university did was they decided to put it through some, software to they clean it up. And so this is what they ended up with when they like cleaned it up a bit. And then the prominence is really pretty amazing, right? They might have played with the contrast a little bit, but and I guess they had an algorithm to figure out what was dust and what was stars, because they knew what the intended purpose was, right? So that's a star, but all that terrible looking dust is gone. And I think here you can see like this is a star, like for example. But I thought, wow, not only is it a nice picture, with all the stars and so on, but the corona is great, and the prominences are great. I thought this photographic plates, I guess, could really resolve, I think, a huge amount of dynamic range, as Michael was saying. I think that's generally true. That, for example, like Kodachrome slides, they can pack a huge amount of dynamic range, much greater, I think, than any like digital sensor can these days. And so that made me think, oh, wow, if I could get hold of those, I could probably reanalyze everything and maybe better, because I was thinking that in those days, what they could only do was, what they were basically doing was they were visually finding the stars and then measuring the location. But if something was like really dim, like let's say, like I don't think this is a star, but let's say if that were a star and it was very dim, they probably didn't have the ability to really measure it by eye, but if you could like digitize it and so on, you could probably do a better job. And so just as a rough test, what I did was I put it in our software program. Here, let me just find the right folder. And so, for example, so like this is the original like data from 1919 in our software program that we developed for 2024, and it did actually find all the stars which Eddington used. He actually used 7 stars. There's only 6 here because one of them in the cleaned up version they actually cut off for some reason which I won't go into. But all the stars which are there, we were able to find, even the one that's kind of in the corona here. So then I became kind of hopeful. I thought, well, if I could do this with a copy, well, wouldn't it be nice to try it on the real thing? So, and as well, what I could do was, in fact, what also got me sort of hopeful was when I looked at, I could zoom in to the like stars. You know, this is the like our analysis of the centroids of the stars, and actually they looked really good. They were nice and round, and you could really like analyze them very well. You could really find the middle. Like I guess that little X is actually the middle of the centroid, you know, based on various weightings, and it covered a lot of pixels. So they, so the resolution of the plate is extremely high, actually much higher than I think a typical camera sensor is. And so that's another one of the stars. And I thought, wow, this is fantastic. You know, the quality of even a copied plate is really, really good. And this is actually from Eddington's paper. So here, let me like turn off my share because then I'll continue with the story where it gets a little bit sadder. So I knew that these original plates of Eddington from 1919 had been reanalyzed by a professor in Cambridge in 1979. And in 1979, he said that those plates, one was broken, one was cracked, and it wasn't usable, and one was just cloudy, so it wasn't usable. And but he'd obviously remeasured it, and he found, yeah, the analysis done in 1919 was good. So I contacted some of these guys at Cambridge who are now, you know, kind of in retirement age. You know, they were doing the work in 1979. So I contacted the guys, and they said, yes, I remember. He measured it, but the plates were never scanned because I wanted to use scanned plates, scanned data, right? And he said, yeah, those were the early days of, you know, the scanning technology. And so we weren't able to do that. And then I said, you know, and where are the plates now? And he said, no one knows. I said, so they're not in Cambridge, they're not in Oxford, they're not in Greenwich, you know, because the expedition was actually launched as a cooperation between the Greenwich Observatory and Cambridge University, where Eddington was, and they used some equipment actually from Oxford. So I thought, wouldn't it be in one of those 3 places? And they said, no one knows. It seems to have been packed up in a crate and sent to some like UK government warehouse. And so I had this image in my mind of the end of Raiders of the Lost Ark, you know, where you know, the Ark of the Covenant has been put into some government warehouse somewhere. And he said, yeah, if you contact, you know, the Administrative Council of Oxfordshire, you know, maybe they can give you a clue where it might be, if they're there at all, or maybe they threw them out.
Have you tried contacting the Royal Astronomical Society? They don't have them at Burlington House.
I could keep chasing, I suppose, you know, but I thought, wow, I thought this would be easy, but it turns out that I think actually people don't have as much regard for historical things as you would imagine.
But you see, it's time. Like data like that and experiments like that are not perhaps fully appreciated. it's like Apollo missions or whatever, you know, it's only the next generation when it looks back, it realizes just how monumental the stuff is. And then it
Right.
suddenly becomes like of interest again, and people are looking to try and retrieve it and put it on display. So I think, yeah, and unfortunately, it's just a victim of age and time gone
Yeah.
by, but it would be fantastic to find
Yeah.
them. Yeah.
Yeah.
I
Yeah.
was
Then
just
I,
exactly, but I was thinking the RAS would be a very obvious.
yeah. Okay.
Because a lot
Maybe
of
I'll,
things
I'll,
end up there, don't they?
yeah.
Mm.
Because as I said, I know they existed in 1979, but then after that, people seem to have lost track of it. So then I decided, well, the 1922 eclipse was the next one, and there was a very good expedition from Yerkes, this telescope near Chicago, and so they did actually well. They had a couple of years of planning, and it was later, so they did actually even like a better experiment, and they analyzed it and so on. But I never really saw a reanalysis of the actual plates. So then I contacted those guys, and they said, well, years ago we shipped all our glass plates to the University of California at Santa Cruz. Because I guess glass plates, they're big, they're heavy, they take up a lot of room and so on and so on. And so we couldn't keep them here, so we shipped them to Santa Cruz. And so I contacted them, and they had a huge, actually online, I could find a huge amount of listings of photographs from that eclipse, but they were all like more like, okay, here's what the telescope looked like, and here are the people doing it. And then online they had one scan of a glass plate, and I think the plate was scanned in the 1980s or so, not at very high resolution. So I contacted them, and they said, yeah, we could actually rescan that glass plate for you at high resolution. And I said, well, that's great. And what about all the other plates? Because I would have needed like a whole bunch of plates, like calibration and so on, which they took. And then they looked around, and a week or so later, they said, "Oh, that's the only one we have. It's possible the rest were disposed of." So I thought, "Oh no, again." So they kept one as like a souvenir or something, I guess. But one doesn't really get you that far. You need the whole series, which they took. They probably took hundreds, I'm guessing, right? By that point, from what I get, maybe 100, maybe around 100. They probably took of various sorts to calibrate their telescope, and also during the eclipse and after the eclipse. But I thought, oh, again, no one really values that. And as far as I know, they said, and there's no scans as well. So, but then I started reading up on this, and apparently something like 15 years ago, Harvard University raised some money from some rich benefactors and so on. And I think they raised something like $15 million to scan all the collection at the Harvard Observatory, which I guess is a very, very old institution. I think they used to probably even make observations from Cambridge, Massachusetts in those days. But they obviously collected a lot of things, and they actually put the effort in to scan, I think, every single plate at the Harvard Observatory, going back to I think the late 19th century, because they said, you never know when, for example, someone wants to look at an image of a galaxy 100 years ago and compare it to a galaxy now. Maybe there's changes or something like this, which is plausible. And so they went to the effort, but they said it was very, very expensive and time consuming to do that. But they did every single one in their whole collection. But that's generally not the case, I found, which is a bit sad in a way, I thought, particularly because I realized that, wow, those guys with glass plates knew what they were doing. And the resolution, they have an enormous image scale. They're like doing plates which are generally at least 8 by 10 inches, and very long focal length, and so on and so on. So they had some pretty impressive like image quality, I have to say. But I have this sense now a lot of it is lost.
That's what surprised me, Douglas, on that image you showed. There was amazing resolution because, and I didn't expect it because when you look at images from the 50s and 60s of Jupiter and Saturn, they are nowhere near the same resolution as we can get nowadays with telescopes. Is it just perhaps maybe because obviously the response of the medium will be nowhere near as good as monitoring instruments, but was it just that they had um, a lot of sunlight coming in that they were able to keep their exposures down to keep the resolution that it didn't
Well,
get blurry?
well, those good ones, those are all taken with a 4-inch refractor, actually. All the best shots were taken actually with a 4-inch refractor. They had actually two 13-inch refractors stopped down to 8 inches, and those gave inferior results, for reasons we can probably like guess
Mm,
at.
mhm.
Um, and I think it was about, I'm trying to guess, it was around F50, by the way.
Wow. Okay.
It was like 4 inches over 19 feet. So you can probably like calculate that out if someone has a calculator. But as I recall, it was something like F50. Um,
But that's so slow you'd hardly need any filter on it. It must have been just like maybe smoked glass or something. I mean, they wouldn't be creating a huge heat source or anything like that. That's
oh, they
extremely
weren't
slow.
using any filter on it at all for the eclipse. No,
Yeah.
it was coming right through.
Sure, of course, total eclipse, of course. Yes,
Total
yes, yes.
eclipse. Yeah,
Yeah.
I don't think they bothered taking any pictures, when it wasn't totality.
Yeah.
But of course, it's a little bit different in the sense that, they weren't doing this lucky imaging like you would normally
Mm,
do these days with um, with something like Jupiter, right? They were doing a, I'm guessing they took, as I recall, something like 8 plates during something like a 4-minute eclipse, right? So each exposure was like, let's say 30 seconds. So because what you're not in this experiment, you're not trying to resolve some fine features of even the corona. Actually, all they're interested in was the average location of the stars. So they actually wanted to integrate over a long enough time such that the seeing was averaged out, right?
mhm.
So I think they figured they'd need at least 20 seconds, and that's what I found too. If you want to know the exact location of a star over a full field, where you have variations due to air turbulence, you need something like 20 seconds to make sure you've averaged out any local seeing
Mhm.
within the field of view. Um, so I think they sort of knew all that, but they had like I suppose when you're working at f50, almost any telescope is going to be pretty sharp, right? So
Yeah. I went into ChatGPT just to ask it where are the plates kept. So it gave me some locations of copies I've put into the chat there if you want to have a look.
okay, because actually I also did that,
Mm.
and in a lot of cases, ChatGPT or Claude or whatever will say, unfortunately, all the plates were lost.
Oh, okay.
And I saw that because that was the answer that I came up with using ChatGPT. They said, unfortunately, it seems to be the plates were lost at some point.
Mm.
And then I actually asked someone who had some familiarity, and he he didn't specifically say that they were like destroyed or something. He just said
Mm.
no one knows where they are.
Mm. Very good.
So I'm guessing when they take that image of that glass plate as just one exposure,
Yes.
and you're getting
Yes.
that high dynamic range of what we have to do with digital cameras, have to, like what Michael was saying,
Mm.
take a range of them and then put them together. So that's
Exactly.
quite incredible, actually.
Yeah, like I mean, this is a little bit off topic in a way, but I was once thinking about trying to digitize like Kodachrome or like Ektachrome. Was it Ektachrome or Kodachrome slides? Just casual slides. And I did a bit of research on this, and they said if you want to actually digitize what's in a slide, you have to use an HDR technique, and because there's so much depth in that slide that you have to take like a long exposure to capture what's in the shadows, and then a short exposure to capture what's in the sunlight parts, because there's so much information in a slide. And they seem to suggest slides had more depth than like a normal negative, let's say, but I'm not really an expert on it. But then I sort of realized, oh wow, there's so much information in I don't know, the silver halide stuff that people used to use. So then it didn't surprise me when I realized, yeah, these glass plates that astronomers used to use probably do contain a lot more information than you can capture with a normal, like even like 12 bits, let's say 12 or 14 bits. I think it's way more than that.
So when are you going to go to an eclipse then with some glass plates?
Yeah.
You know, you know
Are you
how
gonna
people
learn?
get into things like vinyl. You know, there's this thing.
Yeah.
You know, people listen to vinyl. You know, or they use like vacuum tubes or something like that. It's kind of like that, right? You know, there are people that swear vinyl's much better than digital. Maybe
So
it's
you're
true.
going to learn and
It
try
would
it
be
out.
cool. It would be cool, Doctor. So you have
I
to.
don't think you have to go to glass plates. I think if you really believe that's true, you could probably just use photographic film. And there are people, I mean, you know, maybe there's a case to be made, right, for using photographic film. You know, taking long exposure photographic film might get you to the same place as the sort of HDR technique that we're talking about here, and you can capture it all on film, and then you could bring out all the details digitally afterwards, if you see what I mean. You know, maybe, maybe it's too much
The
trouble.
Yeah.
Can any of you
Interesting.
explain the following? It's sort of distantly related. The deflection of the star positions predicted by Einstein was about 1/2 of that predicted by classical physics. Why does classical physics predict there would be deflection, any deflection of light? Is there an easy way to explain that?
Well,
Any of
actually,
you?
that's a great question because actually, and I mentioned this like a little bit in the Solarchat talk I gave, but in fact, there were three possibilities that like Eddington was investigating. One possibility was light was not deflected by gravity, and you know, for a long time, I think that's what most people would have thought. Like, why would light, which was known to be massless, right? Why would a massless
Right.
thing be deflected by any gravitational field? So that was one possibility. It turns out that in a lot of things about gravity, you can make a kind of Newtonian guess about it. So, for example, if you imagine light had a mass equivalent essentially to E equals mc squared, right?
Right.
Right. So if you said that like light was a photon of some sort, which had a mass equivalent to its energy represented by its wavelength and so on, and you do that calculation, you can actually calculate things like the diameter of a black hole or the radius of a black hole. You can say, like, if you shot a particle up, what is the escape velocity of that particle if it's a photon, right? And that's basically saying what is the and the escape velocity, of course, is the speed of light. So you say, like, at what point would the light go up and then start falling back down again? And that gives you like a kind of estimate of what a black hole radius is. Turns out that in all those calculations, and I remember doing this as a student, it's always off by a factor of 2. And I don't know exactly why, but it's always off by a factor of 2. And Einstein actually did this deflection of starlight early on in his life, I think when he invented the special theory of relativity. And he made this mistake and he was off by a factor of 2. And then several years later, when he invented the general relativity theory, he realized, oh, I made a mistake. I didn't take into account all these subtle effects. So I can't really tell you exactly why it's off by a factor of 2, but a lot of those estimates are off by a factor of 2. And so therefore, the Eddington experiment, it was actually trying to discern which of 3 choices, like no deflection, or a deflection which is kind of a quasi-Newtonian Einstein special theory of relativity one, and then the full general theory of relativity. And it turned out it was pretty clear, even from Eddington's experiments. It was pretty clear Einstein's later theory of general relativity was
but at that
was
time
correct.
there was no clear choice between those first two possibilities. Physics was still cloudy as to whether it was no deflection or a slight deflection,
Right, because they all
physics
believed
was
in
not
the
settled.
particle nature of light still before the general theory of relativity came out. And light being a particle had to have mass, and so they computed a deflection of light.
Yeah,
and it was always off by 2x.
Yeah, but the other idea was if you assumed light was a wave, there was no reason to think it was deflected. But actually, in the general relativity view of gravity, there's no force on a particle. All it is that the space is distorted, right? The space is bent and so on, and so therefore, unlike anything, whether it's a wave or whatever, going through this curved space looks like it's deflected because it's going through a space that's distorted. And so in that case, it doesn't matter if light's a particle or a wave. Anything with a trajectory will follow a distorted path.
And
so that's how it was sort of that's how it was sort of unified.
The canoe or the light particle thinks it's going in a straight line the entire time.
Yeah,
but it's the space that's curved, and we're observing it. So.
Right, and so that's kind of. But at the time, like 1919. I mean, Einstein's general theory of relativity came out in 1915. Special relativity was 1905. So between that period of 1905 and 1915, people started thinking about this question, and then Eddington and his colleague, whose name was Dyson, who probably isn't given enough credit for this, said that, okay, there's these three examples. And I think it was a bit of nationalism too. He said, we British are going to figure this out. I know the Germans want to prove it, and the Americans want to prove it, and the French want to prove it, but we British, we're going to do it. And so they raised £100 for equipment, 100 British pounds for all the equipment that was used for that adventure, and all the travel costs going to Brazil and to off the coast of Africa was £1,000. They raised £1,000 for all the travel, all the donkeys and things like that. So I think the pound was worth more in those days, right? And so they had the money. After the First World War, apparently the British, I guess they were relatively well off, particularly compared to the French or British. And so they sort of said, well, we've got the money and they don't, so let's do it.
It's really good.
Now, if anybody's interested, I have a live feed from my telescope of the sun at the moment. Would anybody be interested to see that?
Let's see it.
Yeah, we'll have a
Let's see it.
Okay, hold on one moment while I do a little bit of prestidigitation here. Can Alexandra okay my
I think you should be able to. I think
I'm not very adept at this, so
there's
give me one moment.
a green button in the middle called share.
Okay. And now I have to go back to there. Yep. Now, and now I have to do the live view right here. Where do I find the
found the
live
green
screen button? Share screen. Yeah.
green,
I see it.
big green button in the middle.
Which screen to share.
Okay. Allow to share window. Allow to share screen. Which one should I choose? Allow to share
green
the screen
will
that
see
shows the live
everything.
sun.
Yeah.
Yeah.
The one that
there
shows
we
the
go.
live sun.
And now let me go back to this live stream here. I should have. It's been years since I shared my screen, so you have to forgive me. So now let me. Oh God, the trouble is you end up with so many windows. I'm sorry, I'm making a mess, Russell. Yeah, it should be there. I don't know quite what's happened here now. Well, let me get it sorted out. You continue with your chat. It'll just take me a
We've got
moment.
plenty of time, Paul.
Yep. Why? So there, and it looks quite different when I'm sharing entire screen. Cancel share entire screen. Maybe that's
There you go.
okay. Okay, well,
Right,
that's
so we
you.
can see that entire screen.
Now
Yeah.
we'll have to go to here, yeah, and then we have to go to sharp cap here. I got this right? No, I have to go to there, and then to there. There, can you see that?
Hey,
Yes.
yeah.
Okay, so it's we're here in the Bahamas, and this is sharp cap, and this is the sun, and it's been mostly sunny today, so that's not too bad. And well, you're all familiar with this. There's nothing new here, but I hope I've got the histogram more or less correct here.
Mhm.
The main hump is here, and I'm not saturating the brightest pixels. And can you see my pointer moving around?
Yeah.
Yes. Yes.
And you see, I have to position the sun over a little bit to the right.
I think you need to go over to the left a bit.
Yes, it needs to go over to the left a little bit because the sweet spot is
Coming out.
it's originally a couple of hours ago when I did the meridian flip, it was in the middle, but it has drifted just a tiny bit over to the right. And because we've been talking, I can't control the telescope remotely. I can do the live stream remotely.
Oh.
The telescope is about 10 minutes walk away. Anyway, so, and it's just recording data. You can see down here that there's now only 3 terabytes on a 4 terabyte disk left. So it's already got quite a few. And I apologize. It's always on resume. So now I'm collecting data. I apologize.
Did you say you're in the Bahamas, Paul?
Yes, we're on an island called Eleuthera, which is a remote island in the Bahamas where we spend the winters. And it has the advantage that the trade winds blow steadily over the island. The island is only about a mile wide on average, and we're on the coast. So the trade wind is blowing. I have a scintillation monitor on the telescope, and the seeing is typically around 1 arc second.
So
And
no bugs.
It fluctuates. What was that, Stephen?
No bugs because you have a constant wind.
Yes, very few bugs at this time of year in the middle of the dry season, and it hasn't rained for probably 2 months, and almost no bugs. That's true. At night, when I work at night, I have to put on long pants and a little bit of mosquito spray, but during the day, it's pretty good. This is why the sun, can you see it's jumping around quite a bit?
Oh, we've lost the lives. We're not on share anymore.
We're not on sharing anymore. Wow.
It sounds like a very tough life, Paul.
Yes.
Very, very tough life.
Not a tough life. Why isn't it sharing anymore? Because I screwed up on something. Let me just go back to there and go back to here. And it's for some reason there's the why would it switch to sharing off?
You must have
allowed to share screen. Okay.
I'm just wondering, when are we going to meet you there for the Solarchat observing session?
Yes. How many rooms do you have there, Paul?
Yeah, well, at some point we have a lot of rooms, and maybe we'll even organize a little solar expedition for if any of you, if we want to get together, not just in a Zoom meet, but in reality. But anyway,
well, you'd have to take a boat to get there, right? Because there's no airport on 1 mile wide, on an island 1 mile wide.
There's a very nice airport. There was a US military base here back in the 60s. They built an excellent 10,000 foot runway.
So it's wider than 1 mile. It's 1 mile wide, but very long.
Yes, 110 miles long.
Oh, okay. Well, that makes a big difference.
But share entire screen maybe, and so not seeing the feed here, right? So,
Yeah.
sorry about this. So there we go.
It
It's
says your
there.
screen sharing. There it is.
Now,
Yeah.
We got it.
can you see the street?
Yes.
Yes.
You can see the
Yeah.
sun here right now.
Hmm.
Yeah, good. So what I was trying to say earlier was that yes, it scooted over a little bit to the right, and oh yes, the sun is jostling around a bit. Can you see that?
Yes.
Yeah.
Yeah.
And that's because of the wind. There's a steady 15-mile-an-hour breeze down there. Okay. It's pretty steady,
That's
but
great.
of course it fluctuates. So I'm using 200 microsecond exposures to try and freeze the moving object, basically. And that seems to work. Okay. There's not much I can do about the breeze because it's because of the breeze that the seeing is good.
Yes.
Hmm.
Awesome.
Anyway, I just thought I'd throw
What
that
telescope
in.
are you using, Paul?
What telescope? It's a Heliostar 76.
Oh, very good. Excellent. Okay. And
And
actually, you have one as well, Alexandra, don't
I
you?
do.
And how
yeah,
you have, okay, you have it now a good few months. So I know the winter obviously hasn't been good, but um,
and Warren uses the Heliostar
and Warren
Oh,
has
you
76
it as
got
too.
well.
clouds.
So
Hmm.
do I.
Yeah,
So
there's a
do I.
little bit of cloud.
And you have
Oh
one,
yes.
Stephen. So yeah,
Mm.
the f- the uh, the feedback seems to be very positive on that telescope.
Yeah. I'm hoping to get to 100 at Nice.
Hmm.
Yes, but I know that you're skeptical about whether your seeing will ever be good enough to. I can see
Mm.
the sun is going behind clouds at the moment, and it's like that all day.
Mm.
Like, obviously, the trade wind as it blows across the Atlantic from Africa, it picks up a lot of moisture, and so there are
Oh yeah.
clouds and then sunny periods all day, something like that. Anyway, all right,
And then
I'll stop that
Hmm.
and go
You
back
need to
to
employ
reality.
a solar observatory director, Paul, someone who's 10 minutes away. They can,
yes, you need
Yes.
one of the natives.
Okay, so now let me go back to here.
Paul,
And,
were you saying that you get 1 arc second seeing over an extended time during the day?
well, on the meter,
Or is
and
that
I
kind of
only
just
look at the yes,
peak
no,
seeing?
no, it will go down to 0.5, it'll go up to 1.5, it'll oscillate, okay?
Hmm,
During completely cloudless periods, there
right.
are periods when it's hovering around 1 arc second, but then it can deteriorate and come back again. But there are long periods when it's only at
Yeah.
depends on the direction of the wind.
Hmm.
But
Hmm.
at the moment, we have this steady trade wind, and then it's very good.
Yeah.
When
And how
you
does that
get
how
yeah,
does that compare to your home location, wherever that may be?
on Long Island, Long Island, New York, it's more variable, I would say.
Hmm.
The best seeing on Long Island is when it's what we call beach weather.
Hmm.
So it's warm, there's a steady south west breeze,
Hmm.
and then the seeing tends to be pretty good. And that's during the summer. And because
Yeah.
it's blowing again across a
Right.
lot of water.
Yeah. Yeah. And can you put a number on it? Let's say.
I haven't used the scintillation meter very much on Long Island, and I know
Hmm.
it does vary a great deal, but it's worse than it is down
Yeah.
here.
Yeah.
Yep.
Because I know like these planetary imagers like Damien Peach, he goes down to the like Barbados or something, right? To get the really good seeing. So I was just
Yes,
curious.
I'm sure it would be much better on Barbados because the trade is absolutely constant there.
Mm,
Where we are, we're close enough to North American continent that we get a lot
mm,
of cold fronts, especially in the winter, and that screws things up. It's only when it settles down and you get that constant trade wind blowing that
mm.
we get the good seeing. The downside is, of course, there's huge amount of humidity in the air, probably 80% humidity at the moment.
Mm.
Mm. Mhm.
And then when
Anyway.
that trade wind gets to my house, it's called a hurricane.
Yeah, I've never tried it during a hurricane. The main problem is it can suddenly start raining at any time. I mean, you can't
Yeah, that's
predict.
the problem here too. That's the
And
problem here.
So all I do is I have large plastic bags. I throw over everything. I sprint down there, put the bags over, and turn off the power. And hope. And then 5 minutes later, it's sunny again. So
Mm-hmm.
anyway.
Yeah, that's how it is here. And you can never depend on the cloud or the weather forecast. It's never accurate. And
You're on the North Carolina coast, right?
I'm on the Georgia coast,
Georgia
right
coast.
at the Florida state line.
Yeah, but
And,
very close to the ocean.
3 miles from the ocean, and we live on the inland waterway in the marsh. So it's
do you
never
get good
accurate.
seeing when there's a steady breeze off the ocean?
The seeing here is unbelievable.
Excellent. Okay.
Yeah.
So what's the best long period of seeing you could ever get?
I can't put a number on it either, but it's border of 2 or 3 here almost always.
Yes.
Okay. But we get dense sea fog this time of year, so I'll get perfect, beautiful, steady seeing with crystal black, dark skies from 7 p.m. until 1 a.m. And then you won't be able to see 3 feet in front of you at 1:30 a.m. because sea fog rolls in and just sits over everything.
Okay.
And there's a real risk of their scopes blowing over. And I learned that early on. If you put a plastic bag over my scopes during the rain,
the bag makes it more likely to blow over. Absolutely.
Yeah, that's how I lost my first wave 150i mount.
Yeah, I use the bag basically as guy ropes to tie the whole thing down, and that means I have to check the polar alignment. I just checked it again last night, and it had drifted off by quite a few minutes. So I keep redoing it every night.
Well, everyone says you should put a roof on your observatory. Well, the roof will blow off too. I mean, we routinely get winds 60 to 90 miles an hour in hurricane season. There isn't a roof that will hold up to that.
No. Well, our roofs have held up through Category 4 hurricanes, so touch wood.
I hope that continues.
I hope so too. All right. Anyway.
All right, I'm done.
Anyway, so should we close up now? Because it's been an hour and 20 minutes, I think. But it's been a great chat. Really enjoyed, all of the solar eclipse chat. It's getting me quite excited. I really hope that it's clear in the UK this August.
It's not too late, Alexandra. Flights are Ryanair or EasyJet, whatever. Get in, get out, low cost. No excuses. You don't arrive 2027 and cloudy and say, "Oh, I wish I had gone 2026."
Bye, everyone.
All right, bye, everybody.
Bye.
Yeah.
Till next month.
Thanks, folks. Take care.
Lovely to see you all. See ya.
Thanks. Bye.